So hello everyone. Today I'm here with you all with my new topic, my new video on chapter sound. But now today for class 9, right? So in class 8 you have already studied about the sound chapter. So sound is what? We have discussed in class 8 that sound is just a form of energy which produces in us the sensation of hearing. Right? Right? And one more thing, the cause of sound is vibration that we have studied. Have you ever thought we use one word when standing water is there and diving for stone? What happens? Then this kind of formations take place. So what are these kind of formations? These kind of formations are known as wave. So wave is what? It's just a disturbance. Just a disturbance which travels from one point to another. Right? So if I go further for the wave, that wave is due to the vibrations only. I hope you all know about vibrations. So, but what actually happens? Wave is just a propagation of disturbance in a medium due to the vibrations of the particles. Okay. Now, just a propagation of the disturbance, it means that nothing is carried along with the wave. To prove this, what we can do, we can use the same activity. We will take a cork and keep it in the standing water, then again throw stone. But you will observe the waves will be produced, but the cork will stay at its own place. It means there is no movement of the cork. That means disturbance has moved. Right? So, while studying this chapter, we will be using mainly two things. One is propagation of sound. Propagation of sound, there is the movement of sound from one point to another. And then second is the medium. Medium is the substance or matter through which the sound propagates. Right? Now, the sound and the third one is a wave. Yes. Now, waves, on the basis of its movement, that is the movement of the wave, we can classify sound waves or the waves into two categories. So first is if I talk about transverse waves. My dear children, you have to understand the meaning of the transverse wave. Transverse wave means the waves in which the particles of the system move in a direction perpendicular to the direction of propagation. That is known as transverse wave. Right? Very simple example. If I tie a rope with that end, right, and I will give a jerk, then what you will observe? You will observe a kind of waves produced in that. So what are these waves? In these waves, there is movement in the form of jerk. Like this. Right? So this is we call the zero disturbance level. Now the disturbance is created. Disturbance is passing from one point to another in the rope. The rope is not moving. That means it's a wave. Now it's a kind of transverse wave because it's moving perpendicular. Now this at this point the disturbance will be maximum. Also at this point the disturbance will be maximum. So what does these ups and downs? These ups and downs are actually the movement of the particles in the transverse wave. So how the particles moving in the transverse wave? We will see here. So now in the transverse wave, the string vibrating up. So we can see the crest. This is the upper portion, which you can see here. This is crest, and this downward portion is known as trough. So what crest and trough actually are? So crest is actually the portion of the medium which is directly above the line of zero disturbance. Right? And trough is the region below the zero disturbance. That line, this line which I am mentioning here, O2x, if I take it, so this is transverse wave, right? Next is longitudinal wave. We can also mention. So this is all about transverse wave. Now, same way we will discuss about longitudinal wave. Longitudinal, as from its name, it's very clear. As from its name, it's very clear that longitudinal means along the line. It's very simple. Longitudinal waves are the waves in which the particles, vibrating particles, are moving along the direction of the propagation of wave. Very simple. Now, what is the example of longitudinal wave? If I tie a spring to this point, like this, right? And I add a weight over there. So if I am pushing it down, then it will go up. When I will repeat it, so what we will observe, we will observe different kinds of reasons. That means, what I mean to say, here you can see these wire coils are very far away from each other. Here they are very closer. Again, they are very far away. Again, they are very closer. So that means the regions are generated in this kind of motion. So this region is known as, I would like to tell you what is this rarefaction. And this is known as, this one is known as compression. Now, what is compression and rarefaction? Compression is the region of high density, high pressure, right? In which the particles or the coils are very close to each other. And here, obviously, the pressure will be less, that's why they are moving or they are away from each other. That's why they are here. So, in the longitudinal waves, the disturbance of waves travels in the form of compression and rarefaction, whereas in case of transverse wave, the disturbance moves along the direction perpendicular. Right? Okay. Now, after this, we will understand the production of sound. We know that the vibrations produced, always the sound is produced due to vibration. Now, see with the propagation of sound. If I discuss about propagation of sound, propagation of sound. Before telling you about the propagation of sound, I would like to tell you about mechanical waves and electromagnetic waves. In class 9, we are having one question, why sound waves are called mechanical waves? Mechanical waves are the waves which requires a medium to travel. They are known as mechanical waves. And electromagnetic waves, which do not need any material to travel from one point to another. Right? So, the mechanical waves may be transverse and longitudinal. But electromagnetic waves are always transverse. They can never be longitudinal. Okay. Now we are going to discuss about propagation of sound. That how sound propagates. We are hearing sound at different levels. So let's assume here is the source. There is a source of sound. And here we are having a listener. Source and listener. So we know that sound needs a medium to travel, that's why it is known as mechanical waves. Now source, this is a medium, and that medium will have the particles. I am using the bigger circles so that it will be visible to you. I am naming it 1, 2, 3. There may be number of particles between the source and the listener. And we know very well that the sound is produced by the vibrations. So when the vibrations will be generated, what will happen? It means that the momentum will be there. So when the vibrations will start, these vibrations will strike with the first particle, and the first particle will come in motion. Then the first particle will strike the second particle. But after striking the second particle, first particle will come back to its initial position. Right? Now when it will come back to its initial position, then the second will come in motion, then it will strike with the third, and again it will come back. So this process will keep on going till the sound will not reach the listener. Right? So then the sound will be audible by the listener. This is the way that how the sound travels through medium. Yes. So propagation of sound in air, we can say air having a lot of particles, and these particles are helping the sound to travel. This is the reason that's why we always say that sound cannot travel in vacuum, because sound needs the particles. The vibrations do not go itself. They need something to be there which can transform them from one point to another, that is from the source to the listener, so that they can identify, they can understand the sound, what kind of sound is. That is known as propagation of sound. Okay. Okay. The next is we are having the characteristics of sound. Very important characteristics of sound. So in characteristics of sound, characteristics of sound. In class 8, we have already studied few characteristics. That is, if you remember, that was loudness, pitch. We have already discussed. Now, same way we are going to discuss one by one these characteristics. Then wavelength also, amplitude also, frequency also, time period also. So these are the characteristics. First, I am writing. First is wavelength. That will be denoted by lambda. Then second is frequency. Frequency will be denoted by nu. Then we have time period. That is denoted by t. Then we have amplitude. Right? So these are the characteristics which we have discussed. Right? And one more we are writing here, that is speed of wave. Speed of wave will be denoted as u. Right? Amplitude we can also denote with the help of capital A. Like this. Now, if I represent this wave in the form of a disturbance like this, so dear children, you can see on the screen, I'm mentioning here, then I will explain. This is lambda. This is T. So lambda is what? Wavelength. So wavelength is what? Distance between the two consecutive crests or two consecutive tops. So consecutive crests are first one is second. So consecutive means कि बिल्कुल एक साथ. Next ये start यहाँ से हुई, then it will reach here. तो पूरा एक जो distance है दो consecutive crest के बीच में, that is wavelength. तो इसका यूनिट जो होता है वो हम यूज करते हैं Armstrong. Armstrong means 10 raised to power minus 10 meter. Okay. Next is amplitude. Amplitude is the maximum displacement. You can see this is the point at the maximum displacement, and again this is graph is coming down. So that is the maximum displacement is amplitude. Then we have frequency. Frequency is the number of vibrations per second. That is frequency. Time period, it is the time taken to complete one oscillation. This is starting from this point O, then O2, X, Y, Z. One oscillation means when one crest and one drop. So this is one oscillation. The time taken to reach from O to Y, that is the time period, and the unit of time period is second. Unit of frequency is hertz, that we have already discussed. Then speed of wave, the speed of wave is the speed with which the wave propagates or the move right? Yes. Then we have these are the five characteristics of sound. Wave. That is the characteristics of sound wave. Now there is a relation which is very important formula. First formula for this chapter, that is speed is equal to wavelength into frequency. Speed is equal to wavelength into frequency. That is V is equal to lambda into V. This formula will be used in this chapter to solve out the numericals. If you need the numericals, you can just message me, drop a message in the video so that I can send you the soft copy for the numericals to practice. Okay. Now we are going to discuss about very important thing. The major difference which you have to understand about earlier we have discussed the characteristics of sound wave. Now we are going to discuss the characteristics of sound. There are three fundamental characteristics of sound. First is loudness, right? And second is pitch, and third is quality. We can also call it as timbre, quality or timbre, right? So now we are going to discuss these one by one. So first is loudness. So it's better we can discuss it like in this form. It will be easy for you to understand. So what is loudness? It is a characteristic of sound by which a loud sound can be distinguished from a soft sound. I'm repeating, it is a characteristic of sound by which a loud sound can be distinguished from a soft sound. Right? Just when we whisper, a loud sound is produced, it means the loudness of sound depends on the intensity of sound near the ear. So loudness is just a sensation as perceived by the listener. It is the measure of ear's response. We can say ear's response. कि हम कैसा सुनते हैं, sensitivity, right? This is a disturbance for the sound perceived by the ear. जब कोई म्यूजिक चलता है तो it's too loud, just low the sound level. So what is this? This is the disturbance perceived by the ear, right? So that means loudness. Clear? With which we can identify the loud sound from the soft sound. Now there are some characters on which it depends. Let's discuss about the first. It is directly proportional to the amplitude of vibration. Dear children, these things you will never get anywhere else, so please note down this. Directly proportional to the amplitude of vibrations. Amplitude of vibrations means अगर एक ड्रम है, ड्रम पे मैंने एक हल्का सा ऐसे धप किया, sound will be produced. Yes, produced, but low sound, low loudness. But if I will try to give the more energy, that means the amplitude will be high, then the loudness will be automatically high. I hope it's clear to all. Loudness is directly proportional to the yes. Then second, it also depends upon the distance between the source and the listener. जितना ज़्यादा distance, right? उतना ही क्या होगा कम sound. कैसे? If the distance between the source and the listener is more, then the next loud sound will be there. But we can say, and I can put color, inversely proportional. Inversely proportional to distance between source and listener. Right? Then we have the third. So it depends directly on the density of the medium. Depends directly on density of medium. I hope the meaning of density is very clear to all. Density of medium. Density means larger density, loudness of sound is measured in decibels, right? And the softest sound a human can hear, softest sound that can be 10 decibel. dB means decibel. That is a unit of loudness. Just keep in mind. Then we have pitch. Pitch is shrillness. We can distinguish a man's voice from a woman's voice because of the shrillness. This is that characteristic of sound which helps us to distinguish between male and female voice, right? Very simple. And it depends upon the frequency. How it depends upon the frequency? Like this is the sound wave. One wave is this, right? And another wave is this. So what's the difference? This is low pitch. This is high pitch. Why it is low pitch and high pitch? You can see here the frequency time interval is same, but the more number of waves are there. Here we are having only 2 waves, but here 1, 2, 3, 4, almost 5. So 5. So that is frequency is high. So pitch will be more. Higher the frequency, higher the pitch. Right? So it depends upon pitch. Then we have quality or timbre. Quality or timbre is that characteristic of sound which help us to distinguish between the sound of same pitch and same loudness. Right? In this song, there are so many musical instruments, violin, guitar, tabla. तो उन सबको हम easily identify कर सकते हैं. That characteristic is quality or timbre. Right? Apart from this, we can helps. I can mention here helps to distinguish between sound of same pitch and loudness. That is pitch. Then after this we are having tone. A sound of single frequency is called tone, and note, a sound of mixed frequency. If you mix a number of tones, then it will become note. Right? A musical instrument produces the sound of several frequencies. That is known as note. Okay. Now last but not least for the lecture 1, that is speed of sound in different media. Speed of sound in different media. Speed of sound in different media. We know that the sound travels fastest in solid and slowest in liquids, that we have studied already. Speed of sound is the rate of transfer of disturbance from one point to another. That means which in turn depends upon the particles. जितना ज्यादा पास में पार्टिकल्स होंगे उतनी ही ज्यादा जल्दी जल्दी डिस्टर्बेंस ट्रेवल करेगी, जितना दूर होंगे उतनी ही स्लो करेगी. That's why sound travels fastest in solids and slowest in liquids. Yeah. That means it depends upon the density, we can say. And secondly, the speed of sound depends upon temperature. Speed of sound is highest in solids, then in liquids, then in gases. Secondly, depends on temperature. My dear children, temperature means degree of pressure, right? So it increases on increasing the temperature of a medium. Clear? So speed of sound we consider 346 meter per second in this chapter in air. That will be used in numericals. Then you might have heard about sonic boom. Sonic boom means whenever something is moving more than the speed of sound, 346 meter per second. That is sonic boom. Sonic boom is always जो होता है हमारे rockets, jet planes, all are moving with the sonic, supersonic sound, supersonic speed. I can say. So that is sonic boom. Whenever the sonic boom is produced, there are a lot of disturbances generated, large amount of energy, और इतनी ज़्यादा large होती है कि sonic boom can produce अगर जो है low level पे अगर हम fly करवाएंगे उनको, so sonic boom को जो jet planes है, then जो vehicles हैं वो scatter करेंगे, even they can go. Even hearing problem भी हो सकती है, तो there are number of problems which can be rise due to sonic boom, right? So thank you very much, children. I hope you have understood this chapter. So in all these topics, if you have any doubt, you can leave a comment. I will definitely help you. And for the next topic, wait for the next video. Thank you so much.